We're going to talk about other parts of our circle, our central angle, our minor and major arcs. Okay, the actual section is 10.2. It's on page 285 of your student journal. Okay, it's finding arc measures. Please note, once again, there are a bunch of different vocab terms, some of which you may recognize, some which you could intuitively probably figure out. By the end of the lesson, hopefully you can go through and fill this out in your own words, draw a quick picture. Okay, measuring arcs at the bottom there. I want everyone to read that themselves. Make any notes you need. Okay, so one thing I want to point out first, a minor arc. This says the measure of arc AB. When I'm dealing with the measure of arc, please make sure that you notate this in some way. The measure of arc AB is the angle measure. When we say the length of arc AB, we're actually talking about if we were to stretch a string from here to here and then figure out how long it is. Two complete different concepts. So for those of you that weren't paying attention, let me say it one more time, and then I'm not saying it again. Okay? The measure of arc AB is an angle measure. The length of arc AB is this actual physical length. Okay? Like if you were to stretch a string from A to B and then measure the length of that string. Okay. That'll be a key thing as we progress through this chapter. Okay, so make sure that anytime you see measure, you're thinking angle. The measure of an arc is just the measure of its central angle. So a central angle is an angle that extends from the edge of a circle to the center and back out. That is a central angle. Okay, it has to touch the center of the circle. So this arc measure right here is 50 because this angle is 50. They're the same. This is called a minor arc because it is less than 180. Okay? If an arc is greater than 180, for instance, ADB, notice we use 3 letters to define it. That's called a major arc. Okay, major arcs we generally use 3 letters for there. Minor arcs we usually only use 2. However, I guess you could use 3. Okay, but major arcs we're using 3 letters. The measure of that arc then would be whatever 360 degrees is, subtracted that 50, which is 310. So this is a minor arc here. That's a major arc. The other type of arc you'll talk about here is a semicircle. Tell your neighbor what a semicircle is. Semicircle is what? Half a circle. How many degrees in a semicircle? 180. All right. Very good. So we've already talked about some of these vocab terms. Okay. Let's go ahead and move on. Page 286. Arc addition postulate and congruent circles theorem. I want you to go ahead and read those to yourself. Make any notations. Okay, arc addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of the 2 arcs. That could make you go, huh? I don't quite get that. Well, all that's really saying is this big arc from A to B, notice we trace ABC, A to B to C, is made up of 2 smaller arcs, arc AB and arc BC. That's all that's saying. Which most of you'd be like, yeah, duh. Okay? I mean, that's kind of what's happening. But that's the arc addition postulate. Congruent circles theorem. 2 circles are congruent if and only if they have the same radii. So if they have the same radii, then they're congruent. Okay? However, and I'm going to skip to theorem 10.5, all circles are similar. Okay? Congruent circles have the same radii. All circles are similar. They may just be a different size. They're always the same shape. They always have 360 degrees. And then theorem 10.4, congruent central angles theorem. Go ahead and read that one to yourself. Quick note there. All right, in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding central angles are congruent. So if this is equal to that, then this arc will be equal to that. Same thing here. This has to be equal to this. How do we know those two are equal? Ooh. Sam. Yeah, by vertical angles, right? Vertical angles, they're equal. Therefore, this arc, CD, is equal to BE. Okay. All right, how many think you got it? Okay, I want you to take a look at page 287. Page 287, 1 through 9, please. 1 through 9, work with your groupies. All right, here we go. Ian, what do you got for AB? Yeah, from here to here is minor if we just go from A to B. All right, Brendan, ABC. It is not a major. What is it? Yeah, it has to be more than a semicircle to be major. So this one's a semicircle. Yep. Oh, that's what we do. Okay, ABD, A, B to D. Cynthia? Major, yes. Okay, and BC? Yeah, Drew? Minor. Good. All right, and B, A to C. Isaac? Major. All right, Maddie, DAB, Dab. Major. You didn't even dab when you did it. Major. Yeah, that'd be good. There we go. A to D. KJ. Yeah, minor. Minor. All right, and C to D. Lexus. Yes, also minor. Good. All right. I'm getting messier. Yep, we are supposed to find the measure. Okay. So if we know that this is 40, we could calculate. Now, before I'd fill all that out, and then I'd just come over here and find all angle measures. So if I want to find this angle measure right here, AED, I'd have to calculate 40 and take it away from 180. What's that?
How do you know if that's half? Do we have to do the other side first?
No, it's a straight line with sim. It's half, yeah. Yep. So that's 140, which means AD, arc AD, is 140. Okay? We also know that DC, we already have that one, that one's 40. Okay? They tell us this is perpendicular right here, which means this is 90. And that one is 90. Okay, so arc AB is 90. Arc BC is 90. This is 180 because it's a semicircle. And ABD is 90 and 40. We combine those two, right? ABD, 180 and 40, which is 220. Okay, BAC. We've got to put together BAC. We've got to put together 90, 140, and 40, or 90 and 180, which is 270. And then DAB. Yeah. DAB, we've got 140 plus 90, which is 230. Okay, in the circle above, tell whether ABC is congruent to ADC. How many say yes? Yeah. How come? Cynthia? Good. Both measure 180. They're both semicircles. All right. Any questions on those? Okay. Number 10 and 11. Off you go. All right, circle K, find the measure of DE if I go 30, 55, and what is 180? All these have to add up to 180. This would be 95, because 180 minus 30 minus 55 equals 95. Okay, this right here is 55 by vertical angles, and 30 and 95, or 55 and what, is 180, however you want to do that. Say 180 minus 55 gives us this angle, which is 125, and that is DE. So 125 degrees. Okay, so technically we didn't even need that one, I guess. All right, find the value of x. Dude, what does all this have to add up to? 360. So we'd say 5x plus 75 plus 2x plus 40 plus 70 equals 360. Okay, or 7x plus 75 is equal to 250 if you move these two things over. 7x is then equal to 175, and x is 25. 25 degrees. Very good. You can check it. Tell your neighbor how you can check that out.
You could have also gotten 25 from just doing 5x is equal to 75 plus 2x.
Do we know those are congruent?
Oh, wait, yeah, let's try.
Hey, how could you check it? Yeah. Yeah, plug it in. Everything should add up to 360. If you calculated out the 25, put it in here, you got 125 here, and then 75 plus 50, or 125 there. It just happen to be the same. Why are we talking when I'm talking? You got all this? Have a seat, man. You're walking onto my stage in the middle of my show. Unbelievable. Okay? All right. Find the value of x, find the value, measure of AB. AB happens to be 125. All right. Very good. Any questions? All right.